All right, so welcome back. For those listening online, this is a live recording of our class. We are wrapping up compound interest and introducing reducing balance depreciation as well. So I want to direct your attention to the first paragraph here, compound interest compounded once per year. So just have a look at your handouts. The first thing is the recurrence relation. So remember, every recurrence relation has two parts. The first part tells you where you are starting in the sequence. So in this case, this is how much money I opened my bank account with. The second number, or the second equation I should say, tells me how fast the money is growing. So remember, we are using a geometric sequence, and a geometric sequence means every time I go forward in time, I am multiplying. Specifically by this number, capital R, which appears in the recurrence relation. And last lesson we said capital R equals 1 plus lowercase r over 100. So the formula is there, where lowercase r is the annual interest rate. So for example, if I tell you I am earning compound interest at a rate of 6% per year, then lowercase r would be 6. Okay? That's what we did last lesson. Today, we're going to add one more layer on top of this, and this is technically an introduction to the Year 12 course. So I just taught this to my Year 12s yesterday, and this is as hard as it will get for this topic. So what we're going to do today is we're going to say, instead of compounding one time per year, I'm going to compound more than once. How many of you have a bank account? Put your hand up. Almost all of you. Chances are, if you have a bank account and you're earning compound interest, you're probably getting interest every month or every day. And that's actually better. The more often you are paid interest, the better, because they recalculate the amount of interest every time you are paid. So I'll show you what we mean. So the first thing I want to say is, when we set up this capital R value, instead of using 1 plus lowercase r over 100, we are going to use this instead. We're going to take lowercase r divided by p. And you might ask, well, what's this p about? This is going to mean how many times we are compounding in 1 year. So what I'm going to do now is just guide you through this table at the bottom, and I think this is going to make sense. So the question to keep at the back of your mind is, how many times in 1 year? All right, so let's start with the first one, and feel free to speak up here if you're in the class. If I tell you that something is annual, like an annual general meeting, how often does it happen? Yep, or 1 year. So if I were to say it happens p times per year, what value of p should I assign for annual? So you can fill this in. If something is annual, as we did last lesson, we're going to use p equals 1. How many quarters are there in a whole? 4. So you might not have heard of this before, but it's very common in business to use a quarter to refer to 3 months. 3 times 4 is 12. Okay? How many months in a year? 12. So if I tell you that compound interest is compounding monthly, that is, you are being paid every month, we're going to use p equals 12 in the formula above. All right. How many weeks in a year? 52. Okay. Now, a fortnight, just in case we're a bit rusty on this. A fortnight is 2 weeks. So if I know there are 52 weeks in a year, I should halve that number to get the number of fortnights in a year. So the number of fortnights in a year is 26. Okay, for simplicity, we assume we're not dealing with leap years. So I think this year is a leap year, but in every other year, how many days would there be in a year? 365. Okay? We will spend most of our time with monthly, quarterly, and annually. Next year, you will use the bottom three as well. So there's no harm in showing this to you this year because you're going to use it next year if you're continuing with general. All right. I know these formulas for capital R, you might not yet feel comfortable with them. So now what I'm going to do is I'm going to do a couple of examples where we apply it, and hopefully it's going to become a bit clearer. So please turn the page now. So just for your benefit, I will write the recurrence relation again. Where capital R is 1 plus lowercase r over lowercase p over 100. Okay? So this is a very stock standard exam question that I could give you this year or you could get next year. So essentially, all we need to do is set up this recurrence relation by plugging in the correct values for lowercase r and lowercase p. All right, so audience participation here. Can anyone tell me some useful information that's been given in this question that might be helpful for setting up the recurrence relation? 6%. Excellent, okay? So if we know that the interest rate is 6%, that tells us R equals 6. All right, what else is going to be useful? Okay, yes, this is important as well. So this tells us that 6% is the annual interest rate. And sorry, my mistake, we're not setting up the recurrence relation yet, that's example 2. We're just dividing R by P here. Okay, how often are we compounding interest here? Quarterly. So this is going to help you with question 3 in exercise 3H, this example here. Now, how many quarters in a year? What value of P are we using? P equals 4 when it's quarterly. So in that question, what you are asked to do is convert from a yearly or an annual interest rate to a quarterly interest rate. So what we're going to do is we're going to take 6 and we're going to divide it by 4. And that's going to give us 1.5. So I'd like you to write this sentence as well. The quarterly interest rate is 1.5%. So, this will become clearer when you do a few examples, but instead of doing 6% once in 1 year, we're going to do 1.5% 4 times in a year. 1.5 times 4 is 6. But what you'll see is when you compound more than once in a year, you get more money. So this is sort of our bridge between the useless world of simple textbook questions and the real world where practical things happen. Okay? All right, part B. The interest rate is still 6. but the compounding frequency has changed. So what is the value of P going to be now? 12. What word in the question tells you that? Monthly. All right, so P equals 12. So now if I do R divided by P, I'll get 6 on 12, which is 0.5, which means the monthly interest rate is 0.5%. Okay, and just very quickly, what's the value of P in part C? 365 because it's daily. Round your answer to 4 decimal places. Did that not finish on your sheet as well? Is the sentence incomplete?
Yeah.
Okay, that's all right. Okay, so P is 365. We have to round because it'll give us something long. Has anyone got their calculator handy? This is taking a long time to load. 0.016438. Thank you. And if I round that to 4 decimal places, 10164. And if I write this in a sentence, the daily interest rate is 0.0164%. So just give me a nod if this is okay so far. So we're just looking at the interest rate per year, and now we're dividing it up depending on how many times we're compounding in a year. So we're paying monthly, it's 12 times. Paying weekly, 52 times, etc. Okay, turn the page. Now let's put it all together in a recurrence relation. So now it's appropriate for me to rewrite the recurrence relation. V naught equals A, Vn plus 1 equals R Vn, where capital R equals 1 plus lowercase r over lowercase p over 100. Notice that we've calculated this part in example 1. Okay. All right, so let's do the same thing. Let's look for some useful information in the question. Because I won't be there for you in the exam to be really supportive and encouraging. You'll have to do things on your own. So as a class, let's see if we can uncover the important information in this question. So just call it out.
20,000.
Okay. How would you like to use the 20,000, Sean?
Would it be V naught?
Yep, V naught is the value at the beginning. Okay, so that's a good start.
5.4%.
Sorry, what was that, Sean?
5.4% per annum.
Okay, 5.4%. So I'll do this in a different color. Now, what does this word annum mean? Okay, so if you're unsure about that, make sure you make a note to yourself that annum means year, because this is the language that is used next year. They won't say 5.4% per year, they'll say 5.4% per annum. So you're expected to know that annum means year. Which means the annual interest rate, lowercase r, is 5.4. How often is interest compounded though? Please make sure you read the question in full, because if you miss this word, you will write something that is very, very nice, but will not receive any credit. Okay? So we're compounding monthly, which means, in this case, P is 12. Now, what should I do next? Remember, my goal is to write a recurrence relation. I've only got the first part, the V0 equation. What am I going to need to do to get the second equation? Say it again? Yep. So, this part, yeah? So, we can actually just do the whole thing in one go. So let's do that. So I would like you to show this step in your working. Capital R is 1 plus 5.4 on 12 divided by 100. Sorry, I'm going to move this to the other side. Okay, so now that we've calculated capital R, we can now complete the second part of this recurrence relation. Vn plus 1 equals R Vn. So now I just replace the capital R with the value I've just calculated here. So now the second part will be Vn plus 1 equals 1.0045 Vn. There were a few steps in that calculation, so it's okay if you're still processing it. You will get used to it once you've done it a few times. Okay, part B. I've got the recurrence relation. Now I would like to write down a rule. Any ideas? So on the side here, if you've forgotten, you take the starting term and you multiply by the ratio, capital R, to the power of n. You will use this a lot in the last few exercises. So now that I've given you that prompt, can we write down a rule? Yep. Keep going.
Times 1.5.
Very good. All right, that's your rule. Okay, part C. So this is a realistic situation. You'll have this much money someday, hopefully in the not too distant future, after working for a year or two. You'll have some money in the bank. You go away for a year, the money grows. Let's calculate how much that money is going to grow by. Now, there's a trap here. We cannot use n equals 1. N equals 1 is wrong here. Can anyone explain to me why we do not want to use n equals 1 in the rule?
Because it'll be the same number if you multiply by one, won't you?
Yes, I think that's true. Yeah.
No.
So if I calculate n equals 1, how much time has actually passed? Look back at the start of the question. 1 month. N equals 1 is 1 month. So this is a very common mistake in year 12. If you're given a monthly recurrence relation and you're asked for the amount after 1 year. We do not want to use n equals 1 because in 1 year there are 12 months. So we want to use n equals 12. So please take careful note of that. So now all we've got to do is substitute n equals 12 into the rule, which is why it was worth going to the effort to make that rule. So V12 is 20,000 times 1.0045 to the power of 12. And if we do this calculation, we get the following. 21107.135. And the convention is to round to 2 decimal places, to the nearest cent. And the reason for this is, although in cash we can only pay with 5 cents, electronically by bank transfer we can pay with up to 1 cent. So we will actually round this to 21107.14. All right, if you don't have your calculators handy, grab them out because we need to use the solve function here. In part D, we are told how long do I need to wait to get 30,000 in my bank account. So I put in 20,000, it earns interest. Now I go away, and when I come back, I want 30K. How long do I have to wait? So now we've got a situation where 20,000 times 1.0045 to the power of n equals 30,000. Now, because we're in general maths, we don't have the algebraic tools to solve for n, so we will solve for n using the CAS. All right. And if you've forgotten how to do this, grab your calculator. So you want to go to Menu, Algebra, and Solve. Now type in your equation. That's the equation I want to solve, but there's something I've forgotten to do here. What else do I need to tell the calculator before I solve? The calculator will spit out an error if I put this in. Yes, a comma. Very good, Abby. A comma, and then I need to tell the calculator which variable I'm solving for. So here, my pronumeral is n, so I am now going to solve for n. And now press enter. So I'll paste a picture of this into the notes, which you'll get later on Teams. Okay, have a look carefully. The calculator has told us n equals 90.31, etc. Is 90 months enough? So we need 91 months. So in a calculation like this, if you get a decimal, you're going to round up to meet the requirements. Feel free to do the calculation, put it to the power of 90, you'll see it's slightly underneath 30,000. How much more time do we need to write? All right, I think I'll move on. You'll get this all on Teams later. Okay. All right, we'll do 2 more examples, then we'll take a break. I might not finish the handout today. We might finish it off on Friday. I'm just feeling the time has taken a while. So let's finish with these 2 examples, and I'll let you have a go at some questions. All right, example 3. So what we did just now was we started off with a practical situation and then wrote down the recurrence relation. Now we're going the other way. This time I've given you the recurrence relation. Now we want to go back and reconstruct the practical situation. This is a little bit more difficult to do because there is some algebra involved, but it's not too bad. This isn't a question in the example, but can you tell me how much money was put in the account at the start? Yeah, that's the amount at the beginning. The question that you're most likely to be asked is, tell me the annual interest rate. So the yearly rate, lowercase r, and you'll notice I haven't given it to you. I've given you capital R is 1.003. We don't know what lowercase r is. And if you look at the formula I've written, capital R depends on lowercase r and lowercase p. So as you're looking at this question, do we have any information about lowercase p? That's right. Thanks, Caleb. It's in months. So our money in the accounts is growing. It's being multiplied by 1.003 every month, which means interest is being compounded monthly, which means P equals 12. And now we've got everything that we need. So this time, I'm going to substitute these numbers into this equation here. 1.003 equals 1 plus r divided by 12 divided by 100. So there are two options here. One is to use algebra. The other is to use the CAS. Personally, I would prefer that you just use algebra because you need it next year. If you're not comfortable with algebra, you can use the CAS as your fallback. Let's take the algebraic approach here. This is a linear equation for r. So now I just need to apply the correct operations to both sides to solve for r. So what's our first step going to be, do we think? I want to get r by itself here. Blank looks. It's okay. I'll guide you through the first one. So we'll take 1 from both sides, leaving us with 0.003 equals r divided by 12 divided by 100. Fraction means division. So here on the right-hand side, I have divided by 100. To get rid of that, I want to do the opposite. So I will multiply by 100 on both sides. And now if I multiply both sides by 12, I'm left with r equals 3.6. And therefore, the annual interest rate is 3.6%. So, if you don't want to go down the algebra path, we can do it on the CAS. I'll just quickly show you. Mm-hmm. 3.6. All right, last one, and then we'll do some work. What is the value of P we want to use here? Yeah, and which word in the question is telling you it's 4? Quarters. P equals 4. We are asked to find the annual interest rate. So example 4 is the same as example 3. I have just changed the numbers and the compounding frequency. All right, so capital R is 1 plus R over P over 100. We want to find lowercase r. So we set up the equation. 1.0125 is 1 plus lowercase r over 4 over 100. And you can do whatever method you wish. So if you haven't noticed already, this is a bit more challenging than the stuff that we've done so far. At the bottom of this page, these are the questions from the work program you can try next if you're up to date. If you're not up to date, then what I suggest you do is you finish off geometric sequences, 3F, and compound interest compounded annually, which is 3G, and the first part of 3H. Okay, I think we will leave it there. I will not cover depreciation today. I will cover that either by a video for you to watch in your own time or on Friday. Okay, so you can now start some work and let me know if you've got any questions. Yes.